Okay, today we're going to study exponents. And this is let's begin with the squares of a number. The definition is very simple. It's just a notation. If a number A times another number A, and we are going to use a simple notation to denote it. Just A put up index 2, and that's 2 is called the power of the number A. Okay. So for example, if you write 2 times 2, and now we use a dot for the product. Okay. 2 times 2, and then simply write this 2 square. Okay. And similarly, 4 times 4 will be denoted by 4 square. Okay. Well, the geometrical meaning of 4 square, where is the square from? Actually it's coming from the square, right? And the 2 by 2, okay, this will have 2 here and this 2 here and the 2 times 2, and then it's denoted by 2. It's denoted by 2 square, and then of course it's going to be equal to 4. That means you have a 4 little square here. Okay, so that's why it's called the square. The reason is maybe from the geometry. Okay, and the 5 square means 5 times 5. That's 25. Okay. The so-called perfect square are the numbers which can be written as a square for some number. Okay. Perfect square. Let me list all the perfect squares. So perfect squares is 1 square is a perfect square, which is 1. 2 square is 4 is a perfect square, and 3 square equals 9 is a perfect square, right? And 4 square equals 16 is a perfect square. 5 square is 25, 25 is a perfect square. So then 6 square, let's list all of them, which is less than 100, okay? 36, 7 square is 49, and 8 square equals 64, 9 square is 81, and 10 square is 100. Let's stop here, okay? Some of you also memorize 11 square, 12 square, 13 square, and those are the very special squares, perfect squares, we call perfect squares. Okay, now the square could be very large number. For example, this year 2021, right? And if you square it, it's going to be a very big number. Okay, I use a calculator to get this number. Okay, so you have a 40844441. Okay, how many digits does that have? It's a 7. Yeah, 7 digits. Okay, 7 digits. Okay, this is a bigger number. All right, and now in the last class, we studied the reciprocal. Okay, what is the reciprocal of a number? Okay, A, the reciprocal given a number A, the reciprocal is a number. Okay, that is called reciprocal of A. Okay, the reciprocal of A, okay, is a number, so that the product with the original number is going to be 1. So it's a sum number. We denote it by 1 over A. Okay, so that's called reciprocal A, is a number. Okay, so then my question is, what is the square of a reciprocal number? Okay, so question is, what is the reciprocal of the number square? Okay, well, this can be calculated. This actually is going to be, in fact, this is going to be 1 over, it's a reciprocal of A square. And we claim that. And then you have to prove it, okay? It's not easy to prove. You have to prove that using definition, okay? So you have A square times, okay, times 1 over A square. Okay, let's try to prove this is going to be 1. If this is going to be 1 over A, the square of 1 over A is going to be the reciprocal of A square, which is denoted by 1 over A square. Okay, so let's prove this one. This is A times 1 over A times 1 over A, because it's square of a reciprocal of A. And then this can combine, it's going to be 1 times 1 over A, right? then it's a times 1 over a, then it's b equals 1. So that implies 1 over a squared is the reciprocal of a square. So by definition, okay, this implies it's going to be 1 over a square. Okay. Okay. So yeah, we are gradually going to learn some proofs in mathematics. Proof is based on not based on what do you think is true, based on the rules we already set at the very beginning. It's called the foundation of mathematics. Okay, and that was a definition, like what is reciprocal A, and that is going to be notation. Maybe looks like 1 divided by A, 1 over A. Okay, whatever you call it, but that's just this 1 over A. This is just the name of the reciprocal. How about like that? Okay, think about that. Of course, your name is called Alex, so you have a ALEX, right? But it can be, if you become more creative, you say my name is A over E. That's okay. Nobody use that. Nobody do that. Okay, but that can be possible in computer programming, in mathematics. You can name anything using any symbols. Okay, don't just restrict yourself. So when we read it 1 over A, that is the name of the reciprocal of the number. Okay, so this fact is not trivial. This fact is not trivial, and the reciprocal of A squared should be equal to square of reciprocal of A. That fact is not trivial. It looks like a trivial, but it's not trivial. You have to prove it based on very limited rules we have. Okay, so let's move on. Okay, now the next one. Oh, that's easy, right? It's trivial. Let's do it. And let me explain to you. Negative A, square of negative A should be A squared. Okay, what is negative A, right? By definition, this is another notation for the number. We call it negative A. Okay, this is a number when added to, negative A is the number when added to A should be equal to 0. Okay, that's the definition. That's the definition. Okay, and the fact we have here is the fact we already showed that negative A is going to be negative 1 times A. That's a different, okay? Negative 1 times A is a product of two numbers. And negative A is a number, it's negative A, which is a number added to A should be equal to 0. Okay, so that is, I'm not going to go over and prove that why this is true. Okay, but I'm going to use this fact to prove negative A squared is going to be A squared. Why? It's negative, right, times negative, right? So you can move around. It's negative 1 times negative 1, right? And A times A. Now negative 1 times negative 1, as long as you agree, that's going to be positive. Okay, it's going to be 1, and that's why it's A squared. Okay, that's kind of proof. And negative, we have, of course, using another fact, negative 1 times negative 1 should be equal to 1. This is also a fact. Now, we should know from the previous section. So we're using two factors to prove that, okay? And then you get negative A. So remember, negative A squared is always equal to A squared. Now, is negative A a negative number? That's, no, negative A is not necessary to be a negative number, okay? Negative A, because A could be negative, could be positive. So negative A is, for example, if A is negative 2, negative A is going to be positive number, okay? It's not necessarily a negative number, okay? It looks like a negative number, but it's not negative, because A can represent any number, negative or positive. All right, so now we have this, we are using this product. This is the basic rules we should know that, okay? And A times B squared is going to be A times B, right? And A times B. So actually it's AB, AB, And then you, by the computative rules, you can switch these two, right? Then you can regroup them, AA, BB, that's going to be A squared, B squared. Okay, I just proved that, you know. Yeah, this is a rule again, fair. And it's important using those rules for some problems. For example, okay, let's compute, right? Let's compute 2 squared times 25 squared. Well, when you compute this, okay, you can do that 2 squared is 16, you know, right? And then, but that's not the best way to do if we solve the problem like that. You can do straightforward as, 4 squared 16, and then say 25 squared, and then using calculator 6,200, right? Then you do the multiplication again, right? Then you do the multiplication again. So 625 times, 16, and then again P this. But that's not the best way to do. If you use above formula, okay, we call the square root product formula, then this is going to be 4 times 25 squared. And 4 times 25 is a special number. It's 100. So it's going to be 1000. Okay. And that is much better way to calculate 4 squared times 25 squared. Okay. For example, similarly, okay, let's try a different one. We have 8 squared, 125 squared, right? And now this time, when you see this, you really should realize that 8 times 125 is always going to be 1000. Okay, that's also special one, right? 1000 squared, and the answer is, yeah, we have 6 zeros after the 1. Right? So that formula is useful, and you should keep in mind that and use that as needed. Right? So square of a quotient. Now, I should say that in advanced mathematics, we don't use this division symbol. Okay? But in right now, we're in the middle school and switch to the middle high school. We're in the elementary school, switch to middle school. So we still use this division notation. Okay? So what is A divided by B? A divided by B, it's by definition. Remember that it's A times the reciprocal of B. That's the definition. Okay. Yeah, easily. And later on we're going to study fractions. This is also denoted by, okay, also denoted by A over B. Okay, that's called a fraction. A over B, by definition, is A times reciprocal of 1 over B, and it's also your traditional notation is A divided by B. But A divided by this notation is really not very popular. Just like A times B, we are not going to use A times B in the future. We always use A dot B or use AB, just simply without even writing dot. That's product of two numbers. And the A divided by B, usually we will express like A over B, okay? Use a fraction. Okay, anyway, so let's still use the traditional notation and then try to prove that formula is true. Okay, A divided by B squared is going to be A times 1 over B squared, right? Okay, nothing's wrong here. And then the product of two numbers is going to be by the above formula, right? Then, as you know that 1 over B squared is going to be the reciprocal of B squared. So that is our notation, A squared divided by B squared, okay? Now, if you use this notation for the division, then that means A over B squared is going to be A squared over B squared, okay? Okay, so that is a formula. Now, let's try to prove this formula. Now, this formula tells us A plus B squared is not going to be A squared plus B squared, okay? Yeah, this is this indicates these two are not equal. Okay, but some students still believe this is true, and even getting in the colleges, they still write down the wrong formula, and It's not going. There's addition term here, 2ab. There's additional term here, 2ab. Now, okay, let's try to, let's verify this identity, okay? So let's look at the 2 plus 5 when a is 2, right? The left-hand side is 7 squared is 49. Okay, let's see, here's 2 squared plus 2 times 5 plus 5 squared. Should we get 49 also? 4 plus 2 times 2 is 4, 4 times 5 is going to be 20 and 25. And add them together, 49. Indeed, the above formula is true, at least for this specific numbers. Okay. And so let's try to prove it. How do you prove that? Okay. Now the formulas we are going to using is here's formula: a times b times c. So it's going to be ac plus bc. Okay, that's the first formula we're going to use. And another one is a times b plus c is ab plus ac. Okay, those are the formulas. We have a simple formulas, right? Now, if we have a plus b and let's say c plus d, not just a square. If c d, if c is a, b is b is d, then it's a plus b squared. Okay, just let's prove this more general. Right, how many terms we're going to get? I'm going to view this one as one term and then multiply this, right? So this is using the second formula is a plus b c, okay, plus a plus b and d. Okay, we are using the second formula. Okay, this is the first formula, and this is the second formula, right? And then you multiply this out, and a times c is ac, and bc, and this ad, and the bd. So you should get 4 terms. Right, totally 4 terms. Right, and here we're using the first formula. Now, the special case, a plus b and a plus b. Okay, a plus b means c is just equal to a. So we do the same thing as a is to be a square, and then well, we don't need to redo it. We just in the above formula. Let's repeat it. Okay, let's repeat. Yeah, let's repeat it. It's a special case. Okay, so consider this as a one term, then a plus b times a, right? Then a plus b times b. Okay, then you multiply this out. A times a, b times a, and here's a times b and b times b. Okay, then we're going to introduce a simple notation. A times a is denoted by a square. BA is equal to AB, so it's twice AB, and B times B is B squared. All right, this is a very useful formula. Okay, this is a very useful formula. We are going to use it and over and over again. All right, this is a very useful formula. Okay, now let's take a look at the example. Compute, okay, 99 squared plus 2 times 99 plus 1. Okay. Well, if you recognize this is going to be a squared plus 2ab plus c squared, then you can easily solve the problem. Okay. So 99 squared, here's 2a is 99, b is 1, and the 1 is the 1 squared. Right? In the place of b, it is 1, right? So then it's going to be 99 plus 1 square. It's 100 square. Then you get this answer. But if you compute the 99 square first, then plus 2 times 99, and yes, you will still get the right answer, but it's complicated. Okay. All right, so let's really let's try to solve the following problem. Those are the real problems, okay? From the book or from somewhere else. Okay. Suppose you're given this question, right? How many perfect squares are between 1,000 and 2,000? How do you do that? I think they're perfect squares definitely between 1,000 and 2,000. So you should find the smallest positive perfect square and the largest perfect square. Okay, then you can get all of them in the middle between. But you have to do a guess and try. Okay, I know 30 square is going to be 900. 900 is very close to 1,000, but still on the left side of 1,000, right? Here's 1,000. Here's 2,000, right? Has this straight line, and this will be 30 square. It's 30 square is 900. It's smaller than 1,000. And then 31 square. And that's going to be 960. It's pretty close to 1,000. Then 32 squares here. 1,024. Okay, 32 square. So that is the smallest perfect square between 1,000 and 2,000. Okay, now how do we get the other one? Well, I can try 44. Okay, 44 square is going to be a number less than it's 1,936. So somewhere here, 44, right? And then I'm not sure there's any number between this number and the 2,000. So I try 45. 45 is going to be 2,025, which is here. So now you have the largest perfect square and the smallest perfect square between 1,000 and 2,000. So you begin with 32 square, then 33 square, all the way to 44 square. And how many of them? From 32 to 44. Okay, total is going to be 13. Okay, there's 13 perfect square. The 13 perfect square. Okay, so the idea is you cannot list all of them at the very beginning. Just to find the smallest one, the largest one, greatest one, perfect square. Okay, should make it it should be close as close as possible to 2,000. Okay, then you can get rid of. You can get all of them between them. Okay. I'm going to look at this. We do have a formula to find out 1 square plus 2 square, 3 square, 4 square, all the way to 25 square. There's a formula, general formula. Okay, let me list the formulas. But maybe you can think about how to prove that. 1 plus 2 plus 3, all the way to n, is going to be n times n plus 1 divided by 2. Another one is 1 square plus 2 square plus 3 square plus n squared is going to be n times n plus 1 times 2n plus 1 and divided by 6. It's pretty strange. Okay. So those are the two formulas. This formula is not easy to prove. I just gave it. But the first formula, you should know how to prove it. So let's double check. 1 square plus 2 square plus 3 square all the way to 25 square is going to be 25 times 26 times double of 25. It's going to be 50. 50 plus 1, 51 divided by 6. I want to double check it. 5,525 is correct number. Okay, so 25 times 26 times 51 divided by 6. Bingo. Yeah, this is the right answer. 5525. All right, so indeed, but that's a given, okay? I just double check whether this is the correct number. So we are given this, okay? You don't need to compute it. And then you're trying to find the sum of this. How do you use the given fact to get the answer for the new problem. Okay, I like you to think about it. Okay, I'll give you half a minute. Okay, so then I'm going to show you how to do it. Okay, I hope you already have an answer here. So the idea is how to use the original one, right? The given factor to compute the new one. Okay. Well, 2 square plus 4 square, 6 square, 50 square. You see that those numbers are double of the previous numbers. Right? So that is 2 times 1 square, and 2 times 2 square, 2 times 3 square, and the 2 times 25 square. And then use it. You see, you have to show all the details, okay? Even you can solve the problem quickly. But I want to use every step, use the rules given in the book, okay? Don't create your own rules to solve mathematical problems, right? So it's going to be 2 square and 1 square, right? We're using the rules I mentioned at the very beginning. Okay. Yeah. What rule are you using here, right? A times b squared is a squared times b squared. All right. So then this is a common fact. You take it out. Then what is inside is the one which we're given. Okay. So we're given, here's a 4, 2 squared is 4, 5,525. Right? Then you multiply this out. You will get 22102. Right? That. Now let's move on to high exponents. Okay, so you know that a times a times a times a is denoted by a square, right? A times a denoted by a square. But how about a times a times a 3a's? So of course this should be denoted by a cube. Okay, it's called a cube. Okay, and you can have more than 3, 4. It's 4, right? Then then you can have a very big number, right? For example, a times a, right? You have a 2021a, right? Then divided by 2000, a to the 2021, right? In general, okay, if a is not going to be 1, this number is getting larger, larger, larger. So we know that a to the any power, okay, is going to be 1. Okay, a to the any power is going to be 1. Okay, and yeah, and 2 to the n power should be getting larger and larger if we end up getting larger and larger. Okay, so this is yeah. 1 times 1 is going to be equal to 1. Okay, that's obvious. Now, how about -1 to the nth power? Okay, then this is a little bit tricky here. -1 times -1, you have n negative ones, right? So n could be even, could be odd. Okay. So when n is even, you have a pair of many pairs of negative product and negative ones. Okay. So you're going to get positive one. So we can express in the following way: it's positive one if n is even, negative one if n is odd. Okay. Okay. So for example, negative to the power 7 is negative 1. Negative 1 2020 is going to be positive 1 because 2020 is positive. Right? And we also have the following fact. The reciprocal of a to the nth power is going to be a as a reciprocal of a to the nth power. Okay. So using this fact, you can prove that just like what we did for the reciprocal of a square. Right. So this is using that in 1/2 cube. It's going to be given by this. It's going to be 1/. Okay. So now let's mention the very important rule here for the higher exponent. Okay. So let's derive this formula using examples. Okay, a squared times a cubed. Okay, it's going to be a squared is going to be double. It's a notation, right, for a times a, and a cubed is a notation a times a times a. So you have a 2a here, you have a 3a here. Total how many? 5. So you have a 2 plus 3 equals 5. It's denoted by a 5. Okay, so where's 5 from? 5 is coming from the sum of the two exponents and 2 powers. Yeah, 2 powers. Yes. Okay. So using this fact, 2000, 2019 times a to the 2000, yeah, 2011, for example, right? And then you just add them together, a to the 2019 plus 2011, and that is going to be, yeah. So add them together, right? So it's going to be 0 and 3, 0, 2, 4. Yeah. So that is the answer. Okay. Let's try. Yeah, and let's just look at a to the 8th power and a to the 4th power, right? The power 4. Yeah, let's just add them together. A plus 4. That's a to the power 11. Okay. So now let's take a look at some of the formulas. Well, this one, the notation an divided by a to the n, we also denote by this, right? And we assume that m is greater than n. Okay. And this is going, how do you prove that? Why this is just a to the n minus n? Okay. You can prove that using, you can show this is true for using specific example. But maybe that is not as a proof. Okay. What is proof here is we trying to prove in the following way. By definition, right? This is a product of those two, and m is going to be denoted by n minus n plus n. So it's a separate above using above formula, right? And this group together is going to be 1. Right, then a to the n minus n. All right. All right. Take a look at the example. A to the 8th divided by is a square. And that is going to be, if we understand this is going to be the product of those two, that's going to be 8 to the 8 minus 2. So you can express that as 8 to the power of 6. 8 to the power of 6. Okay. And now the next formula is not trivial. Let's take a look at, how do you show that? Let's look at the example first. Okay, that's the example. Right? Example is easy to understand because we are some of you still in the 5th grade, but we are sometimes we prefer using numbers, but does not mean you can use numbers to prove the above formula. If you prove the formula, you cannot assume any specific numbers. Okay, this is just to get some idea, feeling why this formula is true. Okay, so a square, 2 squared and a cube is going to be 2 squared times 2 squared times 2 squared because it's cube, right? It's a 4 cube actually. So now, and how many 2's there? Right? You can add them together, 2 plus 2 plus 2, right? So that's going to be how many 2's there? 3 2's there. How many 3 2's there? So become 2 times 3, okay? There's 3 2's there. So, so you can guess this is true. Now more general, right? You get some ideas how to prove this. Right? Only difference here is just by n. And then instead of 2. Alright? Okay. So by above formula is m plus m plus m. That's called n m there. So just m times n. Okay, so we prove this idea, prove this formula, but we understand this formula using specific numbers first. But compute this. I think we should know first what is it. 1 to another power, right? 1 to the another power is -1, right? We already did that. Okay, and -1 to an even number, that's going to be positive. So now we can do the -4 cube. -4 cube. Okay, -4 is going to be viewed as -1 times 4. Then according to the above formula, it's 1 cube and 4 cube. Okay. -1 cube is going to be -1. 4 cube is going to be 8. Okay. So then the product is going to be negative. Now let's look at the next problem. This is a pretty challenging problem. We're going to find the integers n such that n cube is less than 50, greater than -50. Okay, find the n. Okay, how do you solve this problem? Think about it. Okay, I'll give you half a minute to think about it. Right. Again, you know, we should just like a problem before. We trying to find all the perfect squares between 1,000 and 2,000, right? And the same idea. We trying to get a perfect cube as close as possible, as close to 50. Okay. So we try this. Okay. I think 3 cubed is going to be 27. It's less than 50. 4 cubed is going to be 64. Okay, it's already go. If we draw the strict line here, here's a 50, right? And this will be 3 cubed. That will be 4 cubed. Okay. And then similarly, here's negative 50. I think this will be negative 3 cubed. This will be negative 4 cubed. So we're gonna n, right? When n is clearly when n is this from this picture, it's clear that n should be less than or equal to 3 rather than negative 3. So, or in other words, n is integer, okay? Integer. So n should be equal to negative 3, negative 2, negative 1, 0, 1, and 2, 3. Right, that is the answer. Right? How many integers? Just count, 7. Right? So all right, so now take a look at the next problem. Okay, what is the value of the sum? Okay, I give you half a minute to think about it. All right, hello, yes, let's go back. Okay, so, well, this problem is actually a trivial problem. If you know that 1 to the n, any n power is 1, here's n is a positive integer, okay? Then you just need to count how many ones there. There are how many ones there? 50. So that's 1 plus 1 all the way to 1. Here's 50. So that's why it's 50. Okay. So that's it. So now we take a look at the next problem. Express 2 to the fifth, 8 cubed, 16 square as a power of 4. Now there are many ways to solve this problem. Okay, you can convert everything to the power of 2, then you change it to power of 4. Let's try to do in 2 different ways. Okay. Yeah. Right. So first of all, you notice that let's change it to everything to the power of 4. So 2 to the power 2 to the power of Yeah, 2 to the 5th. And 8 is 2 cube, then cube. 16 is 2 to the 4th power. 2 to the 4th. Okay. Then using the above formula, and 3 times 3 is 9. 4 times 2 is 8. Then you add them together. 5 plus 9 plus 8 is 2 to the 22. But that's not an answer because you have to express as a power of 4. Right now it's power of 2. So it's 2 squared to the power 11 has 4 to the power. That is the answer. Okay. Another way to do it is you at the very beginning you try this, but a little bit more difficult, trying to express every term in as a power of 4. Okay. So 2, yeah. 8 is 2 times 4. 2 times 4 cube, 16 is 4 squared. All right. Okay. Then you will have a 2 to the 5th, 2 cube, 4 cube, 4 and 2 times 4 is 4. Now, how do you deal with this 2 here at the very beginning? Okay. I think 5 is going to be 2 squared plus times 2 to the cube. You see, this is getting more complicated. Then this 2 will be combined. Will be here's a 4 and 4 cube and 4 cube, 4, right? And add them together, 1 plus 3 plus 3. Yeah, it's give me 4 to the 11th. But I think that second method is much more complicated. All right, so now let's take a look at the next one. So when the expression 8 to the power 10, to 10th power, sorry, times 5 to the 22nd power. So if this multiplies them out, how many digits does the number have? Yeah, 8 to the 10th power, 5 to the 22nd power. All right, so how do we get 0? Okay, the only way you can get 0 is 2 times 5. All right, so you just need to know how many factor 5 there and how many factor of 2 there. Okay. Then you can determine how many zeros there. Okay, for example, 2 squared times 5, you still have a 2 times 2 times 5. This 2 gives a 0. Okay. Hi, so let's take a look at 8 is 2 cubed. Okay, 2 cubed. So then it'll be 3 times 10 is 30. So there'll be plenty of 2 there to meet the number 5. Okay, so it's 2 separate. 20 minus 22 is going to be yes, 30. Okay. So it's 8, right? 2 to the 22 times 5 to the 22, right? Okay. So and 2 times 10 to 10 to the 22. So you're going to get 22 zeros at the end. Okay. And the number of digits is determined by 2 to the 8th power. Okay, so 2 to the 8th, right? Is going to be 4 to the 4th power. Okay, so it's going to be 256 times 10 to the 22. Okay, so it's going to be 10 to the 22nd. So it's going to be 22 zeros. Okay, and how many digits does it have? It has 22 plus 2 plus 3, so 25 digits. Okay, 25 digits. All right, so let's take a look at the next problem. Wow, what is the largest integer n for that such that n to the 2000th power is less than 5 to the 3000th power. So we're trying to find the n as large as possible so that this is still less than this number. Okay. Now, of course, those are two big numbers. How do you compare them? Yeah, how to compare them? Think about it. So the power here is too large. It's harder to handle. So what we're trying to do here is going to be simplified. Okay. So 2000 is going to be 2 times 1000. 3000 3 times 1000. So you just needed to look at, okay, they have the same power. This is really equivalent to n squared times 5 cubed. Right? 5 cubed is going to be 125. So find the largest possible perfect square, which is less than 125. I think it's 11. So 11 square is going to be 121. And the 12 square is going to be 144. It's going to be larger than 125, right? So that's why this is the answer. N should be equal to 11. Okay. Okay. So now let's take a look at this number, this problem. You want to find the n such that 3 to the 5th, 2 to the 4th power. Okay, it's going to be 6 to the 6th power. Okay, first of all, you notice that 2 times 3 is going to be 6. Okay, that's obvious. Okay, so I'm going to write. I need so 6 to the 6th power is 3 to the 6th power, 2 to the 6th. Okay. So I need for n, I need 1 3. Right? I need a 2 square. Okay. So that is going to be 12, right? Then you get this. Okay? So you match that. So n should be equal to 12. This should be 0. In order to get 3 to the power 6 and 2 to the 6th power. Right. What is the sum of the digits of the number? Okay, similar idea, right? I just want you see that in order to calculate the product, you have to use this fact. 2 times 5 is going to be 10. 2 times 5 is going to be 10, yeah. Okay, so take a look at 2 to the 2020, 5 to the 2021 times 3. I think you needed to compare those. And the 5 to the 2020 times 5 times 3, right? You separate. Because 2021 is going to be 2000 and 2020 plus 1, right? So the first part is going to be 10 to 2020. Here's a 15. So just 15, 0, 0, 0. You have a 2020 zeros here. In order to find the sum of digits, all you have to do is just find the sum of 5, right? So the sum is just equal to 5 plus 3 plus lots of 0, which is going to be 8, right? No, sorry. Where's the 3 from? It's 1. Yeah, 1 and 5. It's 6. All right, so here's probably this is the last problem. All right, what is the sum of the digits of the number? So similar to the problem we did. Okay. All right, so it's similar. I think I have a lots of 5 there. So 2 to the nth, 5 to the s power. Then here's a 5 square and a 3, right? So that would be 2 times 5, 10. Right, 10 to the s power. It's 25 times 3, right? It's going to be 75. Okay, 75. You have a bunch of zeros. What you have? Yeah, now you have 8 zeros. So what is the sum of the digits? The sum of the digits is clear. 7 plus 5 plus 0, and that's going to be 12. All right. So we are done with today's lecture. I speed up a little bit. And so what do you have to do? You're given the homework assignment. Okay, I usually assign you 20 problems. 20 from the review section, yeah, review part. Okay, at the end of each chapter, there's a list of problems for review, and then also a list of problems for those are the challenging problems. And I have 2 lessons per chapter, for each chapter. So that's why I divide those problems into 2 groups. Okay, so after you take the first lesson, you do the first half. Then after you finish the second lesson, you do the second half. Okay, so please, yeah, when you do the homework, you write down the problems. If the problem is not big, if it's a word problem too much, you just write down the problem number. And you have to show each step, like what I did here in the class. This is very important, okay, to learn this. The purpose to study mathematics here, 3 purposes. Number 1, okay, I want to make sure you learn all the mathematics required for the middle school. You're wondering, well, I learned mathematics in the school. Why you still have to say learn all the required mathematics? Because yes, you probably learn some, but it's not complete. I cannot guarantee all the schools cover all the materials required, and the teachers are doing the same job. Okay, the different teachers are doing different way. Okay, sometimes they just skip some sections. So who knows, right? So there's no uniform textbook. Okay. Second purpose, to improve your problem skill by solving those problems. You need to practice, no matter how smart, how high IQ, you still need to practice. So you need to practice. So through the practice, you understand formula, understand rules better than before. Then finally, you get familiar with all this kind of problem. You will understand deeper. Okay, and you always feel math is easy when you're in a school. As a result, the third purpose, which is also ignored in the public school. Because why? Because teachers really don't have enough time to grade your homework. Okay, so that's really rely on yourself. You should. Okay, so you have to show each step the details when you do the homework. Sometimes I will ask your mother, to take a picture of your homework and show it to me. Okay, and your mother knows or your father knows, okay, how detailed you have to put them. Okay, and when they do the problems, they show you all the steps. You should know that. This is very important to express mathematics in your details, in your logic. Okay. Let's stop here. See you next class.